All right, we are back to Unit 5. Actually, we're starting Unit 5. We are going to be combining functions algebraically today. So we'll be looking at to add functions, subtract functions, multiply, and divide functions today, okay? Before we start, we are going to be looking at just substituting some values into the function and then do a quick review and then go from there, okay? So here's the normal question. It says, given that function f is equal to 2 minus 3x plus 3x squared, we're looking for each of those these three values, f of 0, f of 2, and f of negative 1. Recall, this is just basically function notation. What we do is we substitute 0 for the f of 0 into every single x that we see. So here, I have 2 minus 3x, right? You see x right there, so we are going to write 0 instead. Plus 3 times, again, I see x, so I'm going to put 0 instead. And then we just need to evaluate. So, I mean, anything times 0 is 0, so this is simply just going to be a 2. Okay, similarly for f of 2, again, what you do is you are going to substitute a 2 into every x that you see. Okay, so 3 times 2 plus 3 plus 3 times 2 squared. This is going to be 2 minus 6 plus 12, which is going to be 8. Right, okay? And then you do the same thing for negative 1. You simply, again, plug in negative 1 into every single x that you see, plus 3 times times 3 times negative 1 squared. This is going to be 2 plus 3, and then plus 3. So this is also going to be 8. Okay, so that's what we've done in the past in Math 10. Actually, this is function notation. Okay, so what we're going to be doing today is somewhat, well, some part of it is similar, but we're going to combine functions first. Okay, so here, let's see. It says, given that f of x is root 2x, and then g of x is x plus 3, we're looking for the domain and range of each of those functions respectively. Okay, so for f of x, domain, well, it's root 2x. So recall, it's a square root function, right? So x, we cannot square root negative numbers. So in that case, x, so that means 2x has to be bigger than 0 or equal to 0. Well, that simply means that x has to be greater than equal to 0, right? X simply has to be bigger than or equal to 0 because we cannot square root negative numbers, okay? Now for the range, if you recall from the previous unit, root function looks like this. So before any transformation, of course. So that means we have the range of greater than or equal to 0 as well. Now for g of x, this is a linear function. Recall the domain and range for linear function is all real numbers. So domain is x is element of all real numbers. And same thing for the range. Y is the element of all real numbers. Okay. Now, we are going to subtract them now. Okay, so part B says, given that d of x is equal to f of x minus g of x. So in that case, what is d of x? Well, it says, write the explicit function equation for d of x. So d of x is going to be f, which is square root of 2x, minus g of x, which is x plus 3. So notice how I put x plus 3 in brackets, because we're subtracting, so be careful, it actually end up with minus x and then minus 3. Okay, so be careful. You're subtracting the entire function, not just the x. And then it says determine domain and range. Well, this time the domain, so what you need to do is you got to look at both domains separately, or both functions, or you can look at the d of x directly. So if you look at this, look at root 2x, well, the domain there has to be bigger than or equal to 0. For the x, it could be anything. But because we have to take the more restricted ones, right? Because, I mean, you could say x can be negative here, but if you put it here, it doesn't work. So you have to take the more restricted domain and say that x is bigger than or equal to 0. Whereas the range, this one is less obvious. It's not something that we can tell easily. Okay, so I don't know. Okay, it's hard to tell. So I'm not going to worry too much about this. If you want to figure out the range for these kind of equations, definitely take calculus. Okay, so for those of you, if you've done it already, then you know you can find maximum, minimum with any particular polynomial or any functions with calculus. But since we're in pre-calc, so we are not quite there yet. So we're going to skip for now, okay? So because this is not something obvious, I will definitely expect you to find out the domain range for quadratic functions though, okay? So that's something we know how, but something like this, we don't know how to figure out the maximum or minimum, so we'll skip for now. Okay, so the product f times g. So the product p of x is equal to f, which is root 2 x, times g, which is x plus 3. If you expand this, you get x times root 2x plus 3 times root 2x. Okay, and then we're looking for domain and range. So domain, same thing. You take the more restricted ones since both terms have root 2x, so definitely x has to be bigger than or equal to 0. Okay, now range. This time we can actually tell what the range is. Okay, so if you think about this, since x has to be bigger than or equal to 0, that means this is always going to be either 0 or positive. Again, when you square root something, the answer will always be 0 or positive. Same thing, and if you multiply by something that's positive, so this is going to remain positive or 0. Same thing here. Root 2x is always going to be 0 or positive. And if you multiply that by 3, you are still going to end up with either 0 or positive. And these two will be 0 when x is 0. And that would be the smallest y value that we'll get, because anything else, we will have bigger y values, okay? If you plug in anything more than 0 into x, then you're actually going to end up with some sort of positive value. And if you're adding positive values, it's going to definitely be bigger than 0. So the range is going to be bigger than or equal to 0. Okay, so this one we can actually reason it out, no problem. The previous one we can't. Okay, we can't. So I'm not too worried about it. Okay, so here are the practice questions. I'll let you try it first. Okay, good luck. All right, let's see if you figure this one out. This one could be tricky because of the absolute value function. Okay, let's see if you remember how to deal with it. This is a linear function for f of x, so the domain and range will be both all real numbers. Okay, for g of x, since it's an absolute value function, so if you recall, absolute value function can be broken into two pieces. Okay, it's either positive x or negative x. Okay, so again, this absolute value sign makes it always positive, but it really is a piecewise function. Okay, it's either positive x or negative x. It's positive x if x is already bigger than or equal to 0, right? So then it's already positive. That's why we're just going to keep it as positive. But if x was negative, then the function actually becomes negative x, because if x was negative 5, but we know g of negative 5 is going to be positive 5, right? So if x was negative, to make it positive, you simply throw a negative sign in the front to make it positive. So this is a piecewise function. So g of x is going to be like this. Now, the domain is still all real numbers, right? You can still have any kind of x value. However, range in this case will be bigger than or equal to 0, right? Because we are making everything positive here. Okay, so that part hopefully you get. Part B and part C will be slightly trickier because it depends on the domain, okay? So let's see. So given h of x is equal to f of x plus g of x, so h of x is going to equal to, because g of x is a piecewise function, so the sum, right, f plus g is going to be a piecewise function as well. So f is always x minus 1, that's not going to change. But we are going to add either x or negative x, depending on the x value. Okay, and we can just simply keep going. That means h of x is going to equal to, well, if we collect like terms here, this is going to be 2x minus 1. Oops. And in this case, it's just going to be negative 1. And when does this happen? Well, if we just treat it as positive x, that means x is already bigger than or equal to 0. But we take the negative case if x is less than 0. So there's our h of x, and now we can figure out the domain and range from here. Domain, it will still be all real numbers, right? That's not going to change. However, range is going to be a little bit different, okay? So if it's anything less than 0 for the x value, the y value always remains at negative 1. Well, what happens if x is 0? Well, if x is 0, you plug in here, you get 2 times 0, which is 0, minus 1, which is negative 1. So when x is 0, it is still negative 1. But what happens after that? So if x is bigger than 0, then what happens? Well, let's just plug in x equal to 1 here then, right? That's definitely bigger than or equal to 0. So if you plug in 1, it actually becomes 2 times 1, which is 2, minus 1, that's positive 1. So what happened then is the graph will look like this. You always remain negative 1 until 0, and then it becomes 2x minus 1. So that's the graph. That's what it looks like. So the range actually is going to be bigger than or equal to negative 1. Okay, so you can graph this function quite easily. Okay, so again, anything less than 0 for the x value is negative 1, so that's a horizontal line. And anything more than 0 for the x becomes the 2x minus 1 line, and that looks like that. And you can see the range then would be bigger than or equal to negative 1. Similarly, for p of x, the product, so if you multiply them, again, you should have a piecewise function. You either multiply by x or you multiply by negative x. Okay, and this becomes p of x equals, if you expand this, you get x squared minus x, and this would be negative x squared plus x. And the first one is when x is greater than or equal to 0. The next one is when x is less than 0. Okay, so you will get a different range here. Domain, same thing, all real numbers. Okay, not a problem. Range. Okay, so that's the question. So what does this graph look like? Well, if you notice this, these two functions are basically the same. Watch this. If I factor out negative 1 out, it actually just becomes this. Right? This is basically what it is. So what that means is that if I just draw the entire graph as that. So to draw this, I know I can look at this. I know my x-intercepts would be 0 and positive 1 right here. And because this is a positive parabola, it looks something like this. Oh, mistakenly clicked the eraser button. Okay, so that's what it looks like. But it says when x is less than 0, I am going to have a negative sign here, which means I'm going to flip the graph over the x-axis. So this portion right here actually will be like this. So that part is going to be gone. So here is what the graph looks like. It looks something like this. It looks almost like a cubic function. Okay, so you can see this keeps going up, this keeps going down. Therefore, the range is actually all real numbers here. Okay. So doing a quick sketch will definitely help you to figure out the domain and range, especially range. Okay. But of course, it's not always. We can't always tell. But most of, the ones I'll give you, you should be able to tell. Okay. All right. Example number 2. Let's continue here. So now we're going to involve some square root functions and parabolas here. It says state the domain and range for f and g. Okay. So for f of x, domain, same thing, will be bigger than or equal to 0 as we've seen in the past. Range will also be bigger than or equal to 0, okay, because it's a square root function. G of x, it's a parabola. Domain will be all real numbers. Range, you got to look for the vertex, right? So this, hopefully you remember, is simply you compare this with x squared. You notice that x is being replaced by x plus 2, which just means that we are shifting this graph, translating this graph 2 units left. So here is our vertex, opens up, looks like this. So range actually will be bigger than or equal to 0. Okay. Part B, given that q of x, the quotient, is equal to f of x divided by g of x. So let's write q of x first. F of x is root 2 divided by g of x, which is x plus 2 squared. Okay, so that's q of x. Now we're looking for the domain and range. Now I'll tell you right away that domain is going to be, well, if you look at this, right? If you look at them, this is telling me x has to be bigger than or equal to 0. And this, if you look at them separately, but this one is telling us that x could be anything. So again, you should always take the more restricted ones. Okay, so in this case, x would have to be bigger than or equal to 0. But there is another thing that you need to keep in mind. That is this portion right here. Because we cannot divide it by 0, right? This could be 0. This could be 0. If x is negative 2, then the denominator is going to equal to 0. So you should write that. you should write x cannot equal to negative 2. However, you already say that x has to be bigger than or equal to 0, so this is actually not part of this domain right here already, so you actually don't need to worry about this. But you just need to be careful because this could be x minus 1 squared. In that case, x cannot equal to 1, which is definitely bigger than or equal to 0. Okay, so you just got to be careful. Watch out for the denominator as well. Okay. And now for the range, I think the range is going to be. Is this something easy to tell? We are only considering the positive portion, so I guess the range here will be bigger than or equal to 0. Okay, so the range for this one, again, it definitely has to be bigger than 0 because root x is always positive, x plus 2 squared is always positive, so we know y cannot be less than 0. However, there is an actual maximum that we cannot figure out, so I don't know. It's not something that's easy to tell, but I do know for sure x is big. Sorry, the range, the y values are always going to be bigger than 0. But there's a maximum, and I don't know what it is. And that's okay, because you can do it with calculus. But we're not there yet. So for now, we're just going to skip it. And I mean, you might ask, how come it doesn't keep going up? That is because x plus 2 squared actually grows faster than root x. So you are actually going to divide a bigger and bigger number, and it eventually going to get really, really close to 0. So the graph will look something like this. Right? It's going to go up to a certain value, and then it's start going to decrease. Okay, so that's what the graph is going to look like, but we just don't know what this maximum value is. Okay, and we're not going to worry about it right now. All right, moving on to the third example here. Let's see. It says, consider the function h of x is equal to x squared minus 2x plus 3. Write explicit equations for 3 functions f, g, and n, so that h of x is equal to f plus g plus n. Okay, so part A. It's easy. It's really, really easy, okay? F of x. So basically, we need to come up with 3 different functions, and that when you add them together, it becomes when you add them together, it becomes h of x. So we could simply say that f of x is going to equal to x squared. Oops. It's going to equals to x squared, and that g of x is going to equal to negative 2x, and that n of x, the constant, could just be 3, right? So if you add these 3 together, it gives you x squared minus 2x plus 3. Simple. Part B, very similar, okay? So you could come up with 2 different functions, f and g, so when you subtract them, it becomes h of x. So we could simply say, again, well, I'm just going to answer the next question here. Are these the only solutions? Definitely not, right? We can come up with many, many different ones. I can say that f of x is going to be x squared plus 3, and that g of x is going to be 2x. So when you subtract them, it gives you h of x right there, okay? So there are tons of different answers that you can give. These are just some examples, okay? So are these the only solutions? Definitely not. Okay, last example I need to show you today. P of x is equal to x squared minus 2x minus 3. We want to write 2 functions, f and g, so that p of x is equal to f times g. So notice this is a quadratic function. We're looking for product of 2 different functions. Well, x squared minus 2x minus 3 can be factored. This is going to be x minus 3 times x plus 1. And therefore, you could say that f of x is simply equal to x minus 3, and that g of x is going to equal to x plus 1. So when you multiply these 2 together, you get your x squared minus 2x minus 3. Part B, given that q of x is x minus 8, write explicit equations for 2 functions f and g, so that f divided by g is equal to q of x. Okay, so this one is slightly trickier because of the division and because we cannot divide it by 0. So we need to avoid the denominator being 0 at all times. Otherwise, the domain will be different, and therefore the graphs actually, or the function actually won't be x minus 8 because the domain is different. Okay, so what we need to do is this. We need to somehow multiply x minus 8 with something that we can divide, and I mean, I think we need to multiply by something, and these two have to be the same, right? So you might think, oh, okay, well then what if I just put x and x? You can't, because what if x is 0? Then you're actually dividing by 0. It's no longer x minus 8, okay? So you can't do that. You might think, okay, what about x squared? You can't do that either, right? Because then, again, if x is 0, then that's going to be 0. Well, then what about x minus 1 and then square? Again, you can't do that because what if x is 1? Then that you get a 0 there. So the question is, how do we avoid make the denominator being a 0? This is what you can do. We know x squared is always positive. Sorry, it's either 0 or positive, but it could still be 0. So to make it not equal to 0, you simply add 1. This will never be 0, and it is always positive, right? Well, I guess being positive doesn't really matter. Well, yeah, I guess so. It does matter. You cannot. Yeah, it does matter because you cannot make it positive and negative because that means it's going to go through the x-axis, which we don't want that, right? So you could either make it always x squared plus 1 or always x squared plus 5 or something like that, right? Make it always positive, therefore you'll never be 0. And, you know, you can reduce this and it becomes x minus 8, and it's not going to change. The domain here is going to be the same as the domain for q of x. It's not going to be different at all. So that's what you need to be watch out for, okay? That's it for this lesson. Hopefully it's not too difficult. You're just basically adding, subtracting. The difficult part really is finding the range. That part could be difficult. We will be graphing later on, but not yet. Yeah, so it's just algebra, so hopefully not too difficult for you, okay? Let me know if you need some help. Otherwise, that's it for this lesson. See ya.